Welcome! We're on to Unit 4, Inference for Numerical Variables. In this unit, we build upon the framework from the previous unit for statistical inference with a focus on numerical variables. We'll motivate our discussion with a study titled Acceptability of Workplace Bullying, which explores the relationship between culture and acceptability of workplace bullying across the globe. As part of the study, the researchers collected data using a survey from 1,484 alumni and current MBA students from 14 countries on 6 continents. The survey asked questions on acceptability of work-related bullying, which is defined as giving tasks with unreasonable deadlines or exposing workers to an unreasonable workload. In this plot, we can see a geographic distribution of the countries included in this study. The sizes of the circles on the plot indicate the sample sizes from each country, which appear to be somewhat consistent. The study groups these 14 countries into 6 continents, and we're interested in differences of acceptability of workplace bullying at the continent level. For each continent, an average acceptability score is calculated, where a low score indicates that bullying is unacceptable. The sample statistics suggest that workplace bullying is most acceptable in Asian countries and least acceptable in Anglo countries. However, these sample statistics alone are not sufficient for determining whether the differences we're observing are statistically significant. One of the techniques we will highlight in this unit, analysis of variance, will allow us to simultaneously compare many means to each other and answers questions like whether or not acceptability of workplace bullying varies across continents. Now let's shift our focus to another data set and take a look at the distribution of inflation-adjusted total family income in the US. These data were collected as part of the General Social Survey in 2012 from a random sample of Americans. We can see that the distribution is, as expected, quite right-skewed. Suppose we would like to estimate the median total family income in the US. Central limit theorem-based methods we introduced in the previous unit will not help us here, since we're estimating the median and not the mean. In this unit, we will introduce bootstrapping, which is a simulation-based technique for creating confidence intervals. Bootstrapping takes its name from pulling oneself up by one's bootstraps, which basically means accomplishing an impossible task. Turns out the task is not all that impossible, and we'll find out more about it in this unit. So let's sketch out the topics we're going to cover. We'll start with introducing the t-distribution and using this distribution for inference on a single mean, as well as comparing two means. Then we'll discuss an important but often overlooked topic in introductory statistics, power. We'll then move on to comparing many means to each other using analysis of variance, commonly referred to as ANOVA, and we'll wrap up the unit with a discussion of simulation-based methods for inference on numerical data.